couple of things that you should be aware of already, and then we're going to move forward with some reactions that you may not be aware of, that hopefully you're going to do a lab either today or tomorrow that will help explain some of these things. So for starters, we have our two basic forms of reactions that you should be aware of. A neutralization reaction, which is just an acid plus a base, yielding a salt plus water. And a neutralization reaction is really just a fancy double replacement reaction. It's a double replacement reaction that we've been able to classify because it happens so much in nature. So a double replacement reaction, you can see the metals in this case, which would be A and C, would react with nonmetals or polyatomic ions and then switch places so that A would bond with D and C would bond with B. So we are just going to progress this a little further when we talk about carbonates and their reactions with acids. The other thing you need to be aware of is the 7 strong acids, which are HCl, HBr, HI, H2SO4, HNO3, HClO4, and HClO3 and HClO4. The only thing you have to know about strong acids is that they completely dissociate in water. So if you put HCl in water, it is going to dissolve 100%. You don't have hydrogen chloride anymore. What you have are a bunch of H+ ions or hydronium ions and a bunch of chloride ions. And then the other thing that we're going to need to be aware of is solubility. Some salts are fully soluble, and some salts are somewhat soluble, and some salts aren't soluble at all. This is an example of a salt that's fully soluble, sodium chloride or table salt, and it dissolves 100% in water. So again, if you put some table salt in water, stirred it around, and then you wouldn't have sodium chloride anymore. You'd have a bunch of sodium ions and a bunch of chloride ions. So we're going to take these ideas and we are going to apply them to carbonate reactions. So the basic form of reaction, instead of an acid plus a base yields salt plus water, we're going to add a little wrinkle here where a carbonate, which is somewhat of a base, it's not a strong base, and an acid, and it will react to form carbon dioxide, water, and a salt. The one main difference here, if you notice, I wrote arrows in these reactions pointing all the way forward because they progress 100% in the forward direction, and I used a double-sided arrow in these reactions because some of them are equilibrium reactions, which we are going to talk about more either in the next lecture or the one after that. But it's important to keep in mind that they're different, right? So in these reactions, they proceed all the way. You're not going to have any acid or base left in a neutralization reaction, whereas in an equilibrium reaction, depending on what our substrates are, you might have some carbonate or some acid left. So these are 3 different reactions that I have up here that fit this form. So we have sodium carbonate with hydrogen chloride forming carbon dioxide, water, and sodium chloride. And again, we added a little wrinkle here in that carbon dioxide is produced. And if you notice, the equilibrium here lies very far to the right. This reaction almost goes 100% to the right because sodium carbonate is completely soluble and HCl is a strong acid. So as a result, if you were to see this reaction in a test tube or if you were going to pipette this reaction, you would see lots and lots of bubbles because there would be lots of carbon dioxide produced. This reaction, sodium bicarbonate or sodium hydrogen carbonate with acetic acid forming carbon dioxide, water, and sodium acetate. It's not as much of a forward reaction. This reaction doesn't go to completion as much as this reaction up top does, but it's still, the equilibrium still lies pretty far to the right. This is baking soda, by the way, sodium bicarbonate. And we get to calcium carbonate, which is very interesting because calcium carbonate is insoluble in water, meaning if you put calcium carbonate in water, you would have mostly still calcium carbonate salt crystals. So when it reacts, the equilibrium actually lies to the left. So comparatively, you would see much less bubbles. The bubbles would be carbon dioxide gas in the bottom reaction than you would in the top. So you're going to have to keep that in mind when you play with different reactants, different substrates, and analyze it based on how many bubbles form, color changes, and other reaction substituents that we're going to talk about in the future. Thank you.